Hello everyone. In this video, we're going to be finding the inverse of a function. So f of x is ln x divided by x, and we're going to find the inverse of f. So to be able to solve this problem, we're going to be using a very, very special function, and we've done similar problems before, so if I can find them, I'll try to share a link down below. Okay, great. So let's go ahead and start with what is given, which is f of x equals ln x over x. For some reason, every time I start recording a video, one of my cats start meowing. I don't know why. They shouldn't be hungry. They have water, they have food, they have everything. The only thing they don't have at this point is the attention, of course. They're not getting that right now. Anyways, so to be able to find the inverse of a function, in general, this is what we do. First, we replace f of x with y. So now we can write it as y equals ln x over x. And then we're going to go ahead and switch x and y. Okay? And you can do this in two different ways. You can switch x and y and then solve for y. Or you can solve for x and then switch x and y. It's the same idea. So let's go ahead and actually... how should we do this? Maybe we can do this. Directly solve for x first. Okay, let's do that. So I'm going to go ahead and write this on the left-hand side. My goal is to solve for x, okay? First step, solve for x, okay? That's what I'm going to do first. To solve for x, again, we're going to be using a special type of function. To be able to do that, obviously, even though we wrote it this way, I don't want 1 over x. That's not a very good thing to have. Or is it? Yeah, actually, I can deal with that. Let's find out. Okay, so let me go ahead and write the x, 1 over x, as x to the power negative 1 times ln x, and that is equal to y. Now, we want to put this in a different form, which is actually going to be the following form, t times e to the t. And the reason behind that is this is called the product log. I mean, the function that I'm going to be using, which is also called Lambert's W function. So anytime you apply Lambert's W function on or to t times e to the t, you get t as a result. That's why this function is called the product log, because if you remember with the log function or the ln function, if we apply it to e to the t, we get t. So from an exponential, we get the t, the argument. From a product like this, we have to apply a special function. We cannot express it like the ln function. That's why we have to call that w, okay? So we need to bring this to a t times e to the t form. How do we do that? Okay, here's what we're going to do first. We're going to bring an x to the power negative 1 here. By using properties of logarithms, first step, we're going to multiply both sides by negative 1. Okay, that's going to give us negative y. And we're going to take this negative 1 and bring it over here, because properties of logs tell us you can do that. So this becomes x to the power negative 1 times ln x to the power negative 1 equals negative y. So far, so good, right? Again, my goal is to solve for x, right? That's what I'm going to do first. And that's what we're trying to do. So this is still not in the t e to the t form, but we're so close. How? Well, you can do a couple things here. For example, if you call this t, if ln x to the power negative 1 equals t, then from here, x to the power negative 1 just becomes e to the power t by properties of logarithms, or just by definition. And because ln is base e, so x to the power negative 1 can be replaced with e to the t. So you're going to get t e to the t equals negative y. That's actually one way to look at it. Or you can use an identity. X to the power negative 1 can be written as e to the power ln x to the power negative 1. And when you do that, you get something like this. Ln x to the power negative 1 times e to the power ln x to the power negative 1. And this just becomes your t. Okay? Make sense? Okay, great. Now, substitution is a little safer, I would say. So let's go ahead and use that. because this kind of looks a little complicated, but that's the whole idea, right? Bring it into this form, t e to the t. Great, so now we got it. And now we can apply Lambert's W function. Let me go ahead and move this a little bit away so that we can apply Lambert's easily. So let's put a big W here and big W here, okay? And erase this and put a nice equal sign. Great. Now, when you apply Lambert's W function to t e to the t, you know what you're going to be getting, right? It's going to give you t. Okay, great. Now, the right-hand side is w of negative y. But wait a minute. We said that we were going to solve for x, right? Well, we didn't, but we're close. Now we have to back substitute. What is t? T must be replaced with ln x to the power negative 1. ln x to the power negative 1 equals w of negative y. And of course, you can move this back. So make it a negative ln x equals w of negative y. And then multiply both sides by negative 1 to get ln x because it is better than negative ln x. And we get that. Now we're so close. Remember, e to the power ln x is equal to x. So let's go ahead and do e to the power both sides. E to the power ln x equals x, which is e to the power negative w of negative y. You can totally forget about this and just focus on this. And remember, our goal was to solve for x, and we did. And guess what? By solving for x, because remember, we had y equals f of x, or f of x equals y. And by solving for x, we actually found x equals f inverse of y, because f inverse basically does the opposite. It switches x and y. So this expression right here is equivalent to f inverse of y. Let's go ahead and write it that way. F inverse of y equals e to the power negative w of negative y. But you gotta remember, what was the original problem? It was asking for f inverse of x. Most of the time, we like to express our functions, the original one and the inverse or any other function that we use, we'd like to express them in terms of x. X is usually the independent variable and y is the dependent variable. That's why in this expression, we're gonna go ahead and replace y with x. And remember what I told you originally, there are two ways to do it. You can switch x and y and then try to solve for y, or you can solve for x and then switch x and y. That's what we're gonna do now. This will give us f inverse of x equals e to the power negative w of negative x. So whatever your function is, f of x, this will give you the inverse. And of course, there are two branches of the Lambert's W function. I made quite a few videos about Lambert's W function. Go ahead and check them out. Also make sure to check out aplusbi, which is another channel of mine that focuses on complex numbers. And I also have a shorts channel. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.